Yo, what's up guys? So let's do an example here. So we got rectangle ABCD where M and N are midpoints of the sides AD and DC. If vector AD is equal to vector X and vector CD is equal to vector Y, find an expression for vector MN in terms of X and Y. Okay, so what are we given here? So M is a midpoint of AD, so we know that these two lengths are equal, AM and MD. And then N is a midpoint of DC, so these two lengths are equal as well, CN and this ND. And then we're given AD is equal to vector X, so let's draw AD here just for reference. So this vector AD is equal to X, and then vector CD is equal to Y. So a vector going down this way. Remember, the tail of a vector starts at the first letter C and then the head ends at D. So vector, this is vector CD, and that's equal to Y. Now, what are they asking us for? They're asking us for an expression for the vector MN. So in other words, they're asking for an expression in terms of X and Y for this vector. This vector here is vector MN. Now, if you look closely, the vector MN is the resultant of the vector MD plus the vector DN. So if we draw just this portion of the diagram below here, we would have vector MD plus vector DN, and the resultant of both of these vectors added together would be vector MN. So I took this result here, this MD plus DN equals MN, and I wrote it out here so you can see it clearly. And now let's get an expression for each of these separate vectors, because if we could get an expression for MD and DN in terms of X and Y, then we have an expression for MN as well. So this vector MD, first off, notice how the magnitude of vector MD is equal to half of the magnitude of vector AD, right? Because M is the midpoint of this line AD here. So the magnitude of MD is half of the magnitude of AD. Another thing to notice is notice how MD is going in the same direction as AD. So the direction of vector MD is equal to the direction of vector AD. Meaning that when we want an expression for MD in terms of AD, we'll multiply it by a positive scalar. Because it's going in the same direction. Positive scalar, same direction. So, same direction, half the magnitude. Well, MD, the vector MD then, is just equal to 1/2 of the vector AD. And now, since AD is equal to X, well, MD we could also rewrite as 1/2 X. Alright, so this MD here is equal to 1/2 X. Now let's find an expression for this vector DN. The magnitude of DN is half of the magnitude of our vector CD. Right? Because N is a midpoint of the line CD. So that means that this line segment DN would be half of CD. Now, the next thing to notice is DN is going in an upwards direction. So if we draw DN here so we could see it closer to CD, we notice that the directions are opposite to each other. So the direction of vector dn is opposite to direction of vector CD. So what does that mean? That means that if we want to have an expression of dn in terms of CD, we're going to have to multiply it by a negative scalar. Because a negative scalar means that the vectors go in the opposite directions. So opposite direction, half the magnitude, so that means that the vector dn is equal to negative a half of the vector CD. And since we have an expression given for CD as y, we can just write negative 1/2 y over here. So this vector dn is equal to negative 1/2 y, so plugging that in here, we get minus 1/2 y. And that's equal to our vector mn. So now we have an expression for mn in terms of vector x and vector y. So our final answer ends up being over here in red. Vector mn is equal to 1/2 vector x minus 1/2 of vector y. So let's do a little recap of what happened here. So we're given this rectangle, A, B, C, D. M is the midpoint of AD and N is the midpoint of this length CD. And we have to find an expression for Mn in terms of vectors x and y, where x is equal to vector AD and y is equal to vector CD. So Mn we're able to break down in terms of vector MD plus vector Dn, and the resultant of those is vector Mn, which is what we're looking for. So then we dealt with each of these vectors separately. So we found an expression for vector MD in terms of x and y. Well, MD is the same direction as vector AD, but it's half the magnitude. So because it's the same direction, it's a positive scalar, and since it's half the magnitude, we multiply it by positive 1/2. So we got a final expression for MD as 1/2 of vector x. Now, this next vector dn, the vector dn was half the magnitude of vector CD, however it was going in the opposite direction, so we had to multiply it by a negative scalar. So vector dn is equal to negative 1/2 times the vector of CD, and CD is in terms of y. So vector dn is equal to negative 1/2 times vector y. So vector mn is equal to 1/2 vector x minus 1/2 vector y.